So with 8.3 notes, first day on ellipses, we have our formula up here where we can have two different types of ellipses. We can have horizontal ellipse or a vertical ellipse. Now what would a horizontal ellipse look like? Well, that would just be an ellipse that is longer horizontally, okay? Where a vertical ellipse would be longer vertically. Okay, so it's either just one or the other. And notice the subtle differences, okay? We have the x minus h squared plus y minus k squared. Okay, that's just from circles. The only difference is now we have over a squared and b squared in the denominator, and it's set equal to 1, okay? So the major axis is the a, okay? So notice when horizontal, the major axis is under the x. For the vertical, the major axis is under the y. So let's go ahead and use that information. Let's look at this first equation here, which is an ellipse. We can plug this into our calculator as well. And let's use the information, follow the formulas here and see what we get. So notice, first of all, that the bigger number in the denominator is 25, and that is under the x. Okay, so that tells us the direction is going to be horizontal. Okay, the direction is going to be horizontal. So what would a be? Well, I know that a squared, okay, a squared is 25, so therefore a is going to be 5, b is going to be 3, okay? So what would the center be? Well, the center, remember, is h and k. Well, since they're not listed here, it must be 0 and 0. So therefore, the center is at the origin. And then it asks for the length of the major axis and the length of the minor axis. We'll answer that after we graph. So let's go ahead and graph this guy and see what we get here. Okay, so I'm just going to zoom in a little bit so we can see a little better. Okay, so we know the center is at 0, 0. So I'm going to go ahead and plot that with the center. The center is at 0, 0. Okay, we have a is 5. So that tells us that we're going to go 5 in each direction for the horizontal. Okay, so I'm going to go 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5 horizontally, because that was under the x. So, and then for the y, I'm going to go 3. 1, 2, 3. 1, 2, 3. And this is all you need. We're just going to go ahead and connect as best you can. And we have our ellipse. So what would be the length of the major axis? Well, the major axis is the longer one. So it's from here all the way to here. So it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the length of the major axis is 10, while the length of the minor axis, if we count, 1, 2, 3, 4, 5, 6. And that is our answer. That's all we have to do. Okay, so number 1 was kind of an easy example. Let's go ahead and try another one. All right, so with number 2, okay, let's just use the information that we have. First of all, notice where the bigger number is in the denominator. So this is your a squared, okay? The a squared is always the bigger number, and then the b squared is the smaller number. So if the bigger number is underneath the y, that's telling us that this is going to be a vertical. Okay, this is going to be a vertical where a is 4 and b is 2. The center, okay, so here is your h, and your k is not listed, so the k must be 0. So therefore, our center is 5, 0, okay? And we'll go ahead and answer that question, the length of the major and minor, in just a sec. So first of all, if the center is at 5, 0, 1, 2, 3, 4, 5, 0, okay? This time, since the bigger number, since the a here is 4, that means this is for the y. I'm going to go 4 up and 4 down. Okay, this is our major axis. So 1, 2, 3, 4. The major axis is vertical, okay? And then I'm going to go 2 in the horizontal direction. So 1, 2, 1, 2. And there you go. You can clearly see that this is a vertical ellipse. So when you go ahead and connect, you can see that. So what is the length of the major axis? Well, the length of the major axis would be double from the center to each side. So if this is 1, 2, 3, 4, it's going to be 8. So the length of the major axis is 8, and the length of the minor axis is 4. And there you go. So this is pretty much the extent of what we're doing today. We're just using the formula. I'll do one more of these. Let's see if you can do this one on your own. Okay? So right now, for this next ellipse, we notice that the bigger number is under the x. So this is our a. That is our a squared, while that is your b squared. So this tells you that this is going to be horizontal. Okay, this is going to be horizontal. The a is 6, the b is 3. The center, so here is your h, here is your k, is 1, 2. Okay, so let's go ahead and graph that. So 1, 2, there is your center, not perfectly on there, but 1, 2. And since, again, the bigger number is underneath the x, that means we are going 6 in the horizontal direction. This is a horizontal ellipse. So I'm going 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 in each direction. And then I'm going to go 3 in my vertical. Now we can clearly see that this is a horizontal ellipse. Not the best drawing this time, but there you go. So the length of the major axis then, the length of the major axis would be 12. And the length of the minor axis would be 6, just counting, okay? So from here to here is 12, from here to here is 6. Okay, now we're on the next page. Let's go ahead and just take care of these last two here where we've been given a graph of an ellipse, and let's come up with the equation. So we can answer a lot of these questions here. First of all, it wants us to answer what's a squared and what is b squared. That's going to help us get our equation, okay? So again, just to help us out here, the equations, we have x minus h squared plus y minus k squared equals 1. And if the a is underneath the x, it's going to be horizontal. So for this equation, for this particular equation for number 6, we can clearly see that this is a horizontal ellipse, so therefore we would use this equation, okay? So let's go ahead and answer then. If from my center to each side here, so if I count 1, 2, 3, 4, 5, okay, that tells us that our a is equal to 5. So a is equal to 5. Therefore, a squared is 25. For your b's, for your b, we can see that if I just count, that's 2. So your b is equal to 2. So therefore, b squared is 4. Well, the direction we can clearly see is horizontal. So that tells us, again, we're going to be using this equation where the a squared is underneath the x. Now our center is 2, 3. Okay? So our center is at the point 2, 3. So that tells us that is our h, that is our k. Now remember, they're going to be opposite because it's on the inside. So I can now just go ahead and use that information, plug all this information into this equation, okay? And we end up with, let me go ahead and zoom down here. So what we have here is x minus 2 squared all over 25 plus y minus 3 squared all over 4, and that equals 1. And we are finished. We came up with the equation given the graph. So let's try one more. Let's try number 7. All right, so with number 7, we can clearly see that the direction of this one is vertical. Okay. We have the center. I'll go ahead and just take care of the center right now. That's -1, -2, -3, -4, -1, -2. So our center is -4, -2. So now we need to come up with a squared and b squared, okay? Well, since this time a squared is always the bigger axes. So this is going to be a squared. If a here from the center to here is 1, 2, 3, so that tells us that a equals 3, therefore a squared equals 9. And then b I can clearly see is 1. b equals 1. b equals 1, so therefore b squared is also 1. This is all the information that I need. I can go ahead and start filling this in. I've got x plus 4 squared over, now again, since this is a vertical ellipse, so this is going to be, since this is a vertical ellipse, remember, the bigger term is going to go underneath the y value. So therefore, under the x, we're going to have 1. So 1, the smaller, goes with the x this time. And then plus. So then I've got y plus 2 squared over 9 equals 1. And we are finished.